my kako, aloha nui kako. Like Noah said, mahalo. I'm Natalie, and mahalo for having me today. I was born and raised in Waipi'o on Oahu, and I currently reside in Haleki'ikona, on Hawaii Island. And today I was asked specifically to speak about some of the research I did in graduate school at UH on the potential of ōiwi, or indigenous agriculture under climate change in Hawaii, a mapping study that we did. And so I was also asked to give a 5-minute presentation. So I'm going to try my hardest to keep to that. And so it's just, to preview it, it's very brief, and I touch on a few points, but I can share the citation at the end, and you can look into further detail on all of the methods and things like that. So growing up in Hawaii, we're really confronted with these intense sustainability issues, a reliance on imports, unused agricultural lands all around our islands, habitat loss of our unique native species, which are our kupuna plants, loss of cultural sites because of some of the habitat degradation, like Uncle Glenn was talking about, with invasive animals impacting landscapes and nearshore fisheries. And like many of us who live in Hawaii and call Hawaii home, I always thought, how can we learn from systems of the past to inform our sustainability concerns? And one of those being our ōiwi agricultural system. There's so much interest in our community in restoration of our traditional or ōiwi agricultural systems. For many of us, growing these crop systems goes beyond cultivation of food, because these plants are kin. We descend from many of these plants and crops. And there's also a huge opportunity to restore these proven systems that have these systems of long-term production, long-term food production that are really proven and specifically adapted to this place. But the potential of these systems is really unknown given our past, present, and future environmental and social changes. Sometimes we can't even see, or you can't even find some of where these systems used to exist, because our landscape has changed so much, or socially, people, or maybe like so much has changed on our landscapes, and the value systems and how we perceive our landscapes also is like that. So this research really looked at and in these alluvial plains, usually on our older islands, older valleys. We have dryland agriculture, which sometimes referred to as field systems. It was highly dependent on rainfall. The dominant crop was usually uala, but as you can see from the artist rendering and then the picture, there's also other crops well integrated into these systems as well. And then a third system, agroforestry, which is a multi-crop extensive system that has many perennial and native species intermixed, and really has this multi-story, mimicking a natural forest system, where we have ground cover crops, we have ground crops, we have root crops, and we have shrubs, trees, and other perennials in between. And there are many different forms of agroforestry that was practiced in Hawaii. And the one we modeled here is really, we call colluvial or slope agriculture, and that occurred in the slopes of older valleys. And you can kind of see in this picture of Palava and Molokai. So the lo'i would be in that flat plain, and then we would have colluvial agroforestry on the sloping edges around the lo'i. And so and even though we might know lo'i today as just really focused on kalo, there's of course usually crops on the banks And so it's not just homogeneous, and that there were other species cultivated as well. And so all of these systems were really diverse at multiple scales, at the crop level, integrating different varieties of a crop at the farm level, and then even at the landscape level, protecting different forest patches. And that all was the part of the bigger agricultural system. And it's this heterogeneity at multiple scales that really makes these systems resilient, which means they can bounce back from disturbances and maintain their function. So this could be disturbances like weather events, heavy rainfall, other things that we are expecting with climate change. So when we map these three systems out based upon environmental and climate parameters, this is the resulting map. You see ōiwi in blue, dryland agriculture in red, and agroforestry systems in green. And some of the major results are that these three systems were likely to produce food at levels comparable to what we are consuming today, estimated at over a million metric tons of food, and that agroforestry likely contributed as much food as ōiwi did. And this is important because when we talk about indigenous agriculture in Hawaii, it's mostly always focused on ōiwi, but these other two systems, dryland and agroforestry, were extremely important. And I should have also said, these are just the three main systems that we focused on for the model, but we know that there are other systems that traditionally existed that the model is not picking up, like you can see in Puna and Hilo or Hamakua. There was specific systems tailored to that aina that this model isn't counting. And so when we think about the potential of our traditional agricultural lands now into the future, we really need to consider climate changes, which we're already experiencing in Hawaii, and there's really little to no work on how agricultural lands or food production could shift under climate change in Hawaii. So what we did is we took those three models of traditional agricultural systems, the ōiwi, dryland, and agroforestry, and we modeled them under the three available climate change scenarios that are downscaled for Hawaii. You can see there. And what we found was that under all three future scenarios where the climate is drying and temperature is rising in different levels, most of the lands that were identified as traditional agricultural lands are still in the agricultural zone, meaning that they can be restored or managed without any land use change or zonal constraints. And we also found that in these drier and higher temperature scenarios, that these lands are going to shift more into the conservation zone. So these low land conservation zones are going to be more important when we think about restoration of these systems into the future. And then we collapsed all of these climate change scenarios on top of each other with the current climate, and kind of smashed them all together and intersected them. That's that map that's on your screen right now. And what this is identifying are priority areas of restoration. So 44% of the current modeled area are areas that are identified as being resilient to a wide range of climate shifts. So these are areas that we can actually target for restoration and management now, because they're likely to support these traditional agricultural systems now and into the future. And like, I'm looking at the time, already 10 minutes, I doubled it. So this is my last slide. I just wanted to share an example of an on-the-ground restoration project that we co-managed today with a community-based organization called Lupoheva in Kona. Invaded forests that is traditionally an agricultural site, thousands of cultural sites that are of traditional agriculture nature, and being restored into a biodiverse and bioculturally diverse system. 40% of the outplanted species are native. There's over 63 traditional varieties of indigenous crops throughout the restoration area, and this is a place where Kanaka are reconnecting to Aina. They hosted in last year in 2020 over 36 community work days. And I'll stop there, and I can talk more later, but I don't want to take up too much more time. Mahalo.
Good to see you, Kavika, than we are doing today.